We are solving this equation on the interval from 0 to 2 pi, but not including 2 pi. The first step is to isolate our trig function. Right now it's already isolated. That 2 we can't get out. That's a double angle, so that's part of the angle. So really we're going to begin just by looking where does my first coordinate on my unit circle equal -1. So look at your unit circle and look for that first coordinate equal to -1. And we'll find that what you find is pi. And so we're going to take that angle 2x and we're going to say that that is equal to 2 pi. Now we can start solving for x. So divide by 2. Oh, and actually I forgot. We are supposed, let me just back up here. We are supposed to add on the period. So 2 pi n. All right, then let's continue. So divide both sides by 2. That means everything gets divided by 2, and I get x equals pi over 2 plus, and then see how our 2's cancel, and I get pi n. So if they were asking me for an infinite number of solutions, I would stop here and be like, okay, I'm done. But they want me to list all of the angles on this interval. So I need to start with n equals 0, so I don't add any extra rotation in. What would my x be? Well, that means my x would be pi over 2 plus, well, nothing if I plug in 0 for n. So that's one of my answers. Second, let's look at if our integer is 1. Now, for x, that would mean I would have pi over 2 plus n would be 1, so I'd just be adding 1 pi on. I need to get a common denominator, so I'm thinking, okay, well, that would be 2 pi over 2. So when I add those, I would get 3 pi over 2. And then I'm going to find my solution for n equals 2. Now that means x would equal pi over 2 plus 2 pi. Now at that point I'm going to be like, wait a minute, if I'm adding on a 2 pi to something that's already positive, then that means I'm going to be over 2 pi. So I can stop there and be like, no, this is not going to work. And my real solutions are these first two that I got. So x equals pi over 2 and also x equals 3 pi over 2.